Hey everyone, welcome to another video lesson. So again, we're going to keep our pause from solving quadratic equations to introduce the idea of the discriminant. Okay, so today we will describe the quadratic solutions without actually finding them. So we're gonna look at the quadratic formula, and we're only going to focus on what's inside of the radical, which is called the discriminant. Okay, because it helps you discriminate as to what the type of solutions that quadratic equation has. So the number of solutions is determined by the degree, which is the highest exponent. The solutions are the x-intercepts, also called zeros or roots. And then standard form quadratic is ax squared plus bx plus c equals 0. Okay, so the discriminant again tells you the nature of the solution. So it could be two real number solutions, two imaginary solutions. It could also be one real solution, and in that case, it's going to be a double root. So let's start with that idea. So if the discriminant is positive, meaning you get a positive number as a result of this discriminant here, okay, that means if it's positive, then you have two real solutions. So it's possible that the graph looks like this. Okay, it could either open or point upwards, or it could also point downwards, depending on the value of a. But it does have two roots if you have a positive number as a result of the discriminant. Okay, what about when you have a negative number? When you have a negative number, when the discriminant gives you a negative number, then that means you have two. Notice I have I for the number I, so you have two imaginary solutions, which means the graph could look like this, meaning it won't be intersecting the x-axis, or it could also look like this. As long as it doesn't cross the x-axis, then we know that that parabola has imaginary solutions. Okay. What about when the discriminant gives you a 0? Then that means there is one real solution, one real number solution, but it's a double root. So it could look like this. The vertex is right on the x-axis. Or it could also look like this. It could point downwards instead of upwards. But the point is the vertex is always on the x-axis. Okay, so to that end, let's go ahead and do these next few problems. This video is not going to be long. So first I'm going to notice that a equals 1. For this is standard form quadratic. B equals -3 and c is equal to -28. So then following the discriminant formula, okay, which says b squared minus 4ac. So I have b squared minus 4 times a times c. b is -3, okay. So then -3 squared minus 4 times a is 1, and c is -28. So this is 9, and then -4 times 1 is -4. -4 times 28 is, let's see, what is that equal to? So this is positive, so plus 112. But 9 plus 112 is equal to 121, which means the discriminant, okay, it's a positive number. So what matters here is not what the solutions are, but the fact that this is a positive number. So in that case, then we have two real number solutions. So then we say two real number solutions. So we will be seeing the graph crossing the x-axis at two different points. Okay, the next one. So this is a equals 1, b equals -6, and c equals 9. So then following the discriminant formula, so we have -6 squared minus 4 times a is 1, and c is 9. So then -6 squared is positive 36. -4 times 9 is -36. So then we have positive 36 minus 36, which is equal to 0. Since the discriminant is 0, then that means we have, okay, one real solution, and it's going to be a double. So then we say one real number solution, but it's a double. Okay, all right, so that's second example. Third example, which is the last one, a equals 2, b equals, oh, before I do any of this, let's write this in standard form, and then we need to have a 0 on this side. So I'm going to jump this 6 to this side. So then this is 2x squared plus 3x plus 6 equals 0. So A equals 2, B equals 3, and C equals 6. So then B squared means 3 squared minus 4 times A is 2, times C, which is 6. So 3 squared is 9, minus 4 times 2 is 8. 8 times 6, that's 48. So then this is negative 39. So notice, this is a negative number. So then this one here has 2, and I'm going to use that I, 2 imaginary solutions. Okay, so again, we don't know what they are, but we can determine by using the discriminant. So that's the purpose of this video. Okay, I hope this is not too difficult to understand. I'll see you in the classroom, and thank you for watching. Bye-bye.